Here, our topic is algorithm in computing and programming fundamentals. So, let's see about the first the definition. A set of finite rules or instructions to be followed in calculations or some other problem solving operations. So, what will the algorithm do? Since we just give the input, so based on set of constraints, it will uh, take into the input, and based on the constraints it will produce the output. So what is the uses of algorithm? It plays a crucial role in various fields and have many applications like the computer science, mathematics. In computer science we used to do with the sorting and searching with a complex task like artificial intelligence and deep learning and machine learning, something like that. So on for the mathematics, we used to solve the problems in a mathematical solution, like finding a linear equation or finding the shortest path in a graph or something like that. So then we'll have like operation research. So in that we can do with some decision making like transportation, logistics, and resource allocations. And next will be the artificial intelligence. So in that manner, it is obviously like image recognition, voice recognition, and object recognition, and natural processing, natural language processing, something like that. So in the data science also we used to analyze the data and process the data, and we have to extract the data from the large amount of data in fields like marketing, finance, and healthcare, like that. So the next concept is, what is the need for algorithm? It is for solving complex problems efficiently and effectively. So it like a reliable, more faster and more easier to perform with that. It enables like a computer to perform tasks that will be very difficult or impossible for human to be do with a manual manner. So in that cases, it works with like various fields like as we seen before in the applications like mathematics, computer science, engineering, and finance department. So in that way it analyze the data and make a prediction, and it will make a solution for that problem. So next we see about the characteristics of the algorithm. So we have a lot of characteristics. The first thing is a well-defined input and output. Obviously, we used to give like a well-defined input, and obviously we'll get a desired output based on that, and it is obviously finite. So algorithm must terminate after a finite number of steps only. So clear and ambiguous, and this is expressed in a clear and ambiguous language. Each and every step or instruction should be like preciously defined, leaving no rooms for interpretation. And next will be a deterministic. Each and every algorithm, each and every steps in an algorithm should be deterministic manner, and the algorithm will always produce the same output. No randomness or ambiguity in a process in the deterministic. So next one is a finiteness. Obviously, we'll be getting like a finite number of steps eventually to complete its execution and not run forever. Effective. So it is effective, meaning that it should be capable of being executed or implemented using available resources, including like time and memory. Next is a generalization. So it is used to solve a general class of problems rather than a specific instance. It is applicable to a range of input within a given problem domain. So next is a feasibility. It is practical and feasible to implement. They should not require like impossible or impractical resources for the execution. And next is divisible into smaller steps. Obviously algorithm will just can be broken down into a smaller steps, and this decomposition facilities for understanding and analysis and also for the implementation. Correctness. So it is used to produce the correct output for all valid input. It must be to solve the problem it was designed to address accurately. Efficiency. While efficiency, it is not a strict requirement, but it's desirable. Efficient algorithm accomplish the task with minimal resource usage, such like time and memory. Modularity. It is used to design in a modular fashion with distinct compo compo components or subroutines. This promotes code reuse or very easier maintenance. So next we'll see about the what are the types of algorithm here. So the first one is a brute force algorithm. It is very simplest approach to a problem. So this is the first approach that comes to finding when we started to see a problem. The next one is a recursive algorithm. It is like based on the recursion. It's like a problem will broken into a several subparts and also like called the same function again and again. Backtracking algorithm. So it builds a solution by searching among all possible solutions. Whenever a solution fails, we track back to the failure point, build on the next solution and continue this process till we find the solution or all possible solutions are looked after. Searching algorithm. So this is used for searching element or a group of element from a particular data structure. It is like different types of like approaches or data structure in which the element should be found here. Next is a sorting algorithm. It is arranging a group of data in a particular manner according to the requirement. It is performing this function is called like sorting algorithm to sort a group of data in a increasing or the decreasing manner. Next one is the hashing algorithm. It is like similar to the searching algorithm, but here we used to contain a index with a key ID. So the key is assigned to a specific data. And divide and conquer algorithm. So it breaks a problem into a sub problem and solves a single sub problem, then like merge all the solution to get a final solution. It is like three steps on that. So first is a divide, solve and combine. The next one is a greedy algorithm. So greedy is like to build immediate benefit of a next part. The one solution that gives more benefit will be chosen as a solution for the next part. Next is the dynamic programming algorithm. The concept of using already found solution to avoid repetition calculation of a same part of a problem. So it divides the problem into a smaller overlapping sub-problems and also solve everything. Randomized algorithm. So it is like use random number. So it gives like immediate benefit. So the random number helps in deciding the expected outcome. So the next will be the advantages. It is easy to understand and it is a stepwise representation of a solution for a given problem, and it is broken into a smaller steps. In that way, it is very easier for the programmer to convert into the actual program. So what are the disadvantages in the algorithm sense? We have to write a program based on the algorithm. It takes a long time and also little difficult to understand a complex logic to algorithm. Branching and looping statements are very difficult to show in an algorithm too. So the next we'll see like how to design an algorithm. First, we have to take over with the problem to be solved by using the algorithm. So clear problem, we have to take it off. After that, we have to check with the constraints of a problem to solve to solve the problem. So for that, we have to take an input based on the constraints. Everything will work out and will produce the output. So finally, we got a solution. This is what how it design an algorithm. So for example, in algorithm we used to call like step 1, step 2, step 3, somewhat like that. So in the first step we start with the start word and finally we have to end with that algorithm. So in between that, like we have to declare a variable and we have to like whatever the um, for for getting the output. So if any constraints is there, we have to include on that and we'll get the output. So the steps are like start. First one is here I'll be just giving the example with a sum of three numbers. So here the first is a start and the second step is we have to declare like three variables. Okay, so I have declared like num1, num2 and num3, and with that three numbers we have to add it. So some constraints I have given here, and then after adding I have to store in one variable. For that I have declared like another variable, it's like a name of sum, and then all the adding number will store into the sum. And the next step is so we have to print that sum variable, and the last is the end step. So that's all about it. Thank you.